Hello and welcome back to the Snyk ASPM Masterclass series. Today we're on chapter 4, which is Control the Next 0 Day. Today's webinar is sponsored by Snyk and Sysdig and produced by Actual Tech Media. My name is Scott Becker. I'm the moderator from Actual Tech Media. Now, before we get to today's great content, we have 4 housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues. But if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a 0-day vulnerability playbook from Snyk. So I encourage you to access that resource now and share it with your friends and colleagues. A third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section as well. Just scroll to the bottom and you'll find the link with the details there. Now, finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage those questions, we have a special additional prize for you. It's another Amazon gift card, this one for $50 for the best question. So after the event is over, the Actual Tech Media team will look at all the questions that came in, pick out the very best one, and contact that prize winner. Okay, with all that housekeeping out of the way, let's get to today's fantastic session. So it's my pleasure to introduce you to our speakers today. We have Omer, who's a senior research engineer from Snyk. We've got Alex, who's field CISO from Sysdig. And so, Omer, welcome. I'll pass the floor over to you.
Hi, great to be here.
Yeah, thanks for having us.
Yeah, so I guess I'll just start off with the presentation, as it also speaks a bit about who we are. So the chapter for today is controlling the next 0 day, and it's going to focus about incident response in the application security team. About myself, I'm a senior security engineer at Snyk. Previously, I was working at Enzo Security and application security posture management platform, and there I was the head of research. Previous to that, I worked in other cloud companies like Wix, and I also, before that, I came from the world of incident response and digital forensics, working at the Israel National Cyber Directorate. So I guess overall about 10 or more years of experience, first as a developer and then from the security side of things. I'm gonna move it over to Alex to present himself.
Yeah, I'm Alexander Lawrence. I've been here at Sysdig about 6.5 years. Background in DevOps and in open source. A lot of experience in the higher ed K-12 grouping. Did a lot of instructional technology stuff as well. And overall goal here is to help people understand how to deal with the things that are affecting us in the cloud native world.
So what we're going to be discussing today, I'm going to show a bit about like historical background to how AppSec changed in terms of the attack surface and how we deal with the incidents, and then going over the main key points, I think, for any incident response. Later we'll discuss the movement of shifting left and shifting right, how it's looking today, what's the kind of sphere we live in today in the security world, and then I'm going to show a bit of the challenges and actual example of a playbook for incident response in a modern ASPM based application. So a bit about the attack surface and kind of historically how we got to where we are today. So back when I kind of started, I think, incident response and being in the realm of application, of security in general, and then specifically in application security, the main division of application security and IT security basically was, I think, about the kind of the equivalent size in the domains that each dealt with. Application security was very protecting the deployed application, which means kind of a waterfall way for every step of the SDLC lifecycle. So each point of each stepping stone would have been kind of dealt at the specific stage, and then you could say, okay, this kind of static application version 1 or 2 or 3 is secured because we have done all of these security testings and so on. And the IT security team was very dealing with everything that relates to the infrastructure. First of all, the workstation, any kind of incident response or indication of compromise for any employee workstation, that was in the IT security realm. And then any server that had any indication of compromise or something like that, again, the IT security would respond to the infrastructure side of the event, and then any kind of operation system, third-party updates, all of those were also in the realm of IT security. And then today, when we look at the changes that was brought with the shift left, with agile development and the appearance of the field of DevOps and develop and a lot of automations around infrastructure, we go to the point that a lot of those domains shifted into the application security and the application world, right? So a lot of, let's say, infrastructure as code, so a lot of handlers that were used to be infrastructure and used to be managed by the IT systems have moved to being used by developers. And DevOps, right, are obviously developers, so all of those kind of handlers became applicative. If we talk about CI and CD pipelines, so again, everything is today automated and continuously changing. The application is no longer a kind of a like modern application are no longer like a state that is versioned and very easy to list. It's rather a moving kind of environment with many parts that constantly change and they interact. Obviously, we move to architectures of very small APIs and no single kind of monolith like we used to see more in the past. And that leaves IT security, again, with the workstations of the employees, and also there are a lot of applicative meanings to any compromise of, let's say, a developer workstation. So the IT can have only some extent to understand what has been done on the machine, but rather any kind of access to application kind of shifts back in many ways to the application team. So networking again, and server stations. Also, server stations are a lot less. We used to have actual physical servers, and now we usually use cloud native Kubernetes and so on. So the actual server is just something that we don't really care about, and we are usually think of our environment as serverless, and the all the provisioning that goes behind the stage are less interest of us, right? There are platforms to manage it for us. So this brings a lot of changes and a lot of right shift left focus, a lot of things that are now managed by code. And this also kind of created a rebound effect that a lot of companies and security teams migrated and put a lot of effort on shift left and understanding their codes, their services, and so on. But the actual what is going on dynamically in our runtime or in past events that happened in our runtime kind of got defocused, and now that we can see that there is a lot of rebound effect in order to get that, what I called here the missing link. And we will talk about it a bit more later into context. So getting all that runtime into the right context and understanding from the code which service runs where, it can have a lot of effect on the way that we handle events, incidents, and understanding our assets. So shift right is, I think right now is very important to take a look and see how each company knows, like security teams, not R&D, what the capabilities that they have around the runtime side of things, the dynamic side of things, and so on. And another example of where shift right is kind of important is any kind of third-party services. When we look at our internal code, there's some extent to what we can do. And when we talk about, for instance, right, DNSs that we manage a lot of the times automatically by scripts using whatever service for DNS that is in use, and any misconfiguration there can basically have a lot of effect on our security, right? Let's say we have some subdomain and it has an allow list, and it is on allowed cores, and it is also pointing to some third-party service, like by a CNAME. And then if that third-party service is misconfigured, so someone might be able to have a subdomain takeover and register that domain for his own, to reference to his own IP or whatever, and then we'll have a big application security risk and big application security vulnerability, but we will not be able to tell about it in any way by looking at our internal code, right? Because everything is managed by the third-party service. So that's another example of why shift right is now also, I think, in a lot of security, application security minds. And also I want to talk 2 words about incident response and generally. First of all, incident response come a lot with digital forensics, and the main difference and the focus of incident response is what we're doing in order to mitigate the ongoing threat. That's the main reason why we have the field of incident response, and digital forensics is more into after the matter, and we want to delve in and understand and attribute to better understand what happened. But this should be at the point where we're passed the incident response, and we know that we have contained the incident. So, so again, like we tend to think of incident response a lot of time in teams, and I've seen this many times, that it goes to kind of, okay, there's an attack, someone breached us, and we're now dealing with this incident. But a lot of the time, the incident is not just a malicious attack. Okay, there could be other incidents that require us for immediate kind of response. For instance, I've listed here a few, but anyone who has passed a SOC 2, any company that has SOC 2 type 2 certification has to have a security reporting channel, and has to have, in order to have that, have to have like a scope that defines what they want to address. And they are also obligated, once someone is contacting them about the security vulnerability or something, most of the time those are security researchers, and they're probably interested in publication of that issue. So it turns into an incident, because you can know that someone outside of this organization know of some vulnerability. So that is, I think, probably most organizations' first time that they actually need to attend to incident response. This is kind of the channels that they might not have expected, but start to understand that this is a big task and it costs a lot of time. And once you have a security reporting channel, you need to verify every report and so on. And that kind of leads to the next evolution of bug bounty, where you want to have someone else to manage and do the initial triage, get a better standardization for reports, and not, anyone can report anything and you need to address it, but you get it after it's has the community standards for reporting, and someone checked it, and you can also decide if you want it a private company, a private program where only people you invite and so on, and or a public one. And also this kind of makes you again reactive and have to investigate and create an initial an incident response plan. Another great example, this is, I think, goes mostly for the next 0 days, actually actively exploited in the wild attacks. A great example would be, I think, Log4j or any other type of attack that we knew that it's very easy to do, very easy to exploit, and people are actually actively using it, and it holds a lot of risk. So that's again a state where an organization can say, or security team can say, we're actually in an incident response type of event. And also the case of leaked credentials, again, it's not something very dramatic. I think a lot of us have gotten an email from Amazon or whatever service that say we see like a private key in or credentials in a public repository, and that's the email someone who is the admin get, and then you need to kind of understand what this means. Do I need to do any further investigations and understand what's going on? So again, these are all incidents that goes to sometimes our day-to-day, and a lot of the times we see people, even though incident response is for 90% of the time you're not active or more, you're not in an incident response mode, still when it peaks, you do not utilize the amount of time between incidents to kind of think about what you're going to do, and then you keep thinking of it when you're stressed and at the ground level start to build everything as you go, and it's obviously not the place you want to be. So all of these cost in AppSec load, and that's where organizations start to understand that you need to have a plan, you need to do it in a way that suits the specific organization needs, and also it's just too costly. It costs any kind of security report that comes from someone, it can cost a lot of high kind of personnel. If you have an AppSec team, you know, their time is very valuable to you, and you use it for triaging some of non-relevant events and non-relevant reports and so on. So it's very costly, and you want to make sure that it's managed correctly. So I'll run a bit over this, and then I think we'll incorporate Alex and to the kind of shift left and shift right and understanding the runtime. But generally, I wrote the 6 different key elements for an incident response. And the first one would be your static app data. So this is anything that goes to your logs and repudiation efforts and querying capabilities. You want to know what can you ask and know about your app, which is basically logs that asks what was changed, when, and by who or what, because a lot of things can be done by automations. And that's like the very basic of understanding. Let's say CI, you want to have your CI logs, right? You want to know which build passed and which build failed and when, okay, and who kind of initiated that build. Okay, the next key element I think is the dynamic app data. So dynamic app data goes to everything that is today. It's you can correlate it with cloud assets because they are ephemeral, they keep changing. You don't really care about the specific instance because it can change any minute. It can write auto scale and doesn't hold a lot of data, a lot of information for you. However, you do want to know which kind of application ran well. So you have to understand what are your environments, what are your deployments, what are your registries, and where does it all, and what is the current status, right? So dynamic is where you want to validate that something that you, I don't know, some fix is actually deployed. This is where you have to go and check it. You don't go to see the CI log. You want to see in live that there are no old versions running in production nowhere. Okay, so you have to have that kind of dynamic information. You have to know that the registries does not hold a specific, let's say, node module package that is vulnerable or malicious. So this is where you want to, this is a key element. The next is the assets, is to assess the relevance. And again, this is something that is very an important key element because of the growing size of applications and the growing stack of applications. You want to understand and say, and quickly eliminate all the defocusing assets. So you want to say, I have an incident, it is in production environment or in a third party or in a specific, I don't know, S3 bucket related assets. And we want to say, I want everything that relates to this environment, to this service, or to this data, database, etc. I want everything else to kind of being removed from my focus. And this is also very important, again, when you need to take actions and need to decide whether you're rolling back something, whether you're opposing any kind of change. You want to be as specific as possible to where, to instruct where you want to do it, because it also might cost completely different efforts to deploy something across all the environments rather than a specific environment. And you want to be you don't want to be in a place where you're running after R&D and asking all the questions of back to R&D to understand what's relevant and what's not. You want to be able to do it and give the security value. The next key is timeline. Again, I used to see a lot of response teams that didn't have this at heart. Let's call it. This is really the heart of an IR, is constructing a timeline for the incident, understanding not only what happened when to lead to the incident, or to notice the incident, but also what are the incident response efforts that were has been made, and also put them inside the timeline to understand and see what affected what, and to see that really once you changed, you proxied all requests through whatever, or added some rule for your WAF, you want to say that happened at that point of time, and then we see reduction of requests or any other indication, and this is all this all tells the story of what really happens, and what is effective and what is not effective. Also the defined domains, I would say that this is critical for the team to understand what domain falls on which team member, and also what are their R&D persona, correlating personas. Again, this goes strictly for professionalism. When you go to, if you have something in the realm of your SCM, let's say GitHub, you want the person who knows the exact organization, latest changes, latest, you want it to be the most professional person to ask to lead you to the right answers. Okay. Lastly, I think also practice and document. I mean also creating creating work plans and playbooks. So basically, as I stated before, when you go to IR, like most of the time you're not in an ongoing event. You're just in a standby mode, and you go to whatever is the ongoing tasks, right? Your routine. But an important part of IR is like reacting fast. It's a time critical reactive event, right? So, and most actions are very much similar, very much repetitive, and very and doesn't differ much from different events, even types of events. If you want to audit and see who made the last change in some service, right? It's a pretty repetitive operation of understanding, of getting from the service to the team and to the project, and seeing like the latest whatever changes or pull requests or merges. So in that aspect, the more you practice and write down like playbooks, which doesn't have to be super extensive. They can be very, very simplified and on point. You can get like a ton of value, and you'll see that it's just like a muscle that you can train it, and the secret is also to get a lot of practice through any kind of incidents not real incident, but treating some as incident. If you know that you're lacking in some kind of response, in the past it took you a lot of time to react to something or to understand something, then you might want to say, okay, the next even low-level risk events, but the next vulnerabilities of that sort, the next reports of that sort, I want to treat it as an incident response with what it means, and then kind of get that muscle trained, and also obviously update all the procedures, and write down what you're lacking in, where are your gaps, and have it added to your plans for to eliminate those gaps. Okay, this I'm going to run a bit through it because I think it's less important, but this is again like the current day kind of way that we address incident response. So it's not, like I said before, it's not the waterfall kind of historic way that you're goes to every step of the developing cycle and put on a countermeasure. Today, as part of changes, and you have to be a lot of more reactive. So this is an example of NIST from NIST illustration from the guidance of incident handling. And the idea is that the complexity is kind of everywhere. So you can always kind of prepare, and you always need to prepare, but you always also can be in a state of detection and analysis. So, and again, like I said, an incident can happen not only by your own detection, but it can also being reported by external. So the next part of the slide, I think I'll let Alex here take over.
Sure. Thanks, man. So really what we're talking about here is how do we help enrich and leverage the data that we have in our environments to really inform what we do on the ASPM and response side of things. And so that would be thinking about, when we have applications running, particularly applications in containers, how do we not waste our time dealing with the fluff that also exists inside of those images, right? They typically produce a fair amount of noise. There's a fair amount of things going on in there that are kind of distracting from what is relevant for what I should be doing today, right? And then how do I better utilize my time tomorrow based off of that information that I'm getting? And so really the goal here with Snyk was to figure out how do we help reduce that noise, and how do we help give our time back to developers and to security professionals in order to kind of spend that effort on things that matter more, that matter the most. And so if we think about kind of that whole developer platform, it's really about looking across that whole life cycle of kind of all of the data that we get. So that would be things like the various Snyk offerings, like Snyk open source, Snyk code, Snyk container, the Snyk infrastructure as code, all of these different components. How do I leverage this whole platform in a more novel way to get done what I needed to get done in a time efficient way? And so that would really be about kind of interjecting the data that we get from the runtime process, the deploy and build processes, all of that back into the life cycle that we're going through as we go into the code development aspect, doing the tests and fixes, doing the repository aspect of things, the CI/CD aspect of things. Basically, how can we enrich all of that cycle with information coming from other sources? And so if we think about kind of cutting through that noise, that's really about taking the data that we have at build and enriching it with the data that we have from runtime. So if we have information about what is actually loaded in memory in a container, and we actually have information about which of those libraries have vulnerabilities, which one of those are exploitable, which one of those have active accessibility to the internet or to outside sources, leveraging all of this information and pushing that back into the developer's lifecycle to help kind of prioritize what stuff actually gets done. Sysdig does this in a fairly novel way. It actually instruments each one of the workloads, and it looks at all of the system calls traversing the host from those various applications, right? So from the different containers as they call different things, do an f.write or do a mem open or something like that. They are issuing all these different system calls. Sysdig is looking through all those calls and figuring out which one of them is relevant to which library or process inside of those applications. And so it's effectively profiling all of the different components and then taking different actions. So in essence, Sysdig has always been able to, kill a container, stop a container, publish an event or result from some malicious sort of activity. But we wanted to take that a step further and then enrich that back to the developer's life. Because again, if we can tell them precisely which libraries have a vulnerability or have an exploit that is at risk in production, we can do a lot more to help remediate that early on before it ever becomes a theoretical issue. And so that's where we get this whole notion of prioritizing these vulnerabilities by leveraging the two technologies together. So Sysdig is taking this runtime data out of the production environment, and we're shipping it back into Snyk, into the dev world, so that they can basically figure out what stuff should be focused on today, and then what can we remove tomorrow. Right. When I talk about this, a lot of it is about being able to prioritize where I'm pushing my efforts and where I'm putting my particular focus on a given day, a given week, so I can kind of help set what I want to do. So you might have a particular image that Snyk finds has, maybe 900 some vulnerabilities. After you fix that base image from Snyk's recommendations, you can bring that down to about 40. If you then layer in what is actually in use, that gives you, around 3 or something less. And so you get a very small number of things that are the priority for right now. And really what it comes down to is if I have these 3 vulns that are in use, that are seen by Sysdig, that are actually accessible, I should probably remediate those as soon as humanly possible, right? I should do those today. These other 40 that I have, I should probably go look at them and see, are they not in use? They're just vulnerabilities sitting out there. Is the application never actually calling these things? Then maybe what I should focus on tomorrow or the next week is removing those from the image completely. That way, when I go back through this evaluation cycle, I don't have to spend time remediating stuff that's never actually used. I can lower my risk profile. I can lower the overall stuff that I have to take care of as this image evolves. So basically, the essence of this really is it has the benefit of security posture, but it's really about time, right? If I can isolate down to the stuff that matters the most and remove the things that don't, then I don't have to go through these cycles again in the future. And that lets me focus on the stuff that actually matters for what I want to do. Other than, that whole time element, there's a lot of things around controlling incident response workflows. There's a number of things around being able to kind of manage the risk significantly better and be very pinpoint specific about where I have potential issues or potential risks in that environment. And so really that's the benefit here is that we're able to really hone in on what we need to take care of and how we need to react to those particular things. Across the different filters you'll see in both products, it's really about getting down to what is particularly exploitable, what's accessible to the internet, what you can actually do something now with so you can help remediate those vulnerabilities that matter the most. And so I think that was the key elements I was supposed to talk about here. Omer, if I'm wrong, please let me know, but I think I'm supposed to pass it back to you at this point.
Yeah, no, I think you covered it, and also I think it showed really well how, if you talk about some kind of incident and you want to quickly give a verdict whether it's relevant or not, does it, for instance, let's say a library that is vulnerable is being used and you want to check it and there's I don't know 100 places where it is but only 2 that actually loads up the module that uses it, then not only does it save time, it might make an incident last exactly 2 seconds or 5 seconds if it's not in a relevant environment, like if it's only in QA, rather than spending days of eliminating bogus issues from your inventory, right? So I think that's really a great testament to how you tie ASPM and runtime analysis to bring a lot of value. So thanks.
Yeah, and if we relate it back to kind of real life things, when we had the Log4j incident a few years back now, a lot of our customers were leveraging our joint solution to be able to look for that kind of needle in a haystack, right? They had applications that were vulnerable. They knew that. They saw the vulnerabilities. But when it came to kind of the rubber meets the road of the incident response side of things, where did they focus their time? Where did they focus their efforts? And this type of correlation let them know that, okay, in this production application, I have stuff that's, again, internet facing. It's got the vulnerability. I know that can be exploited. I have to take care of this as soon as humanly possible. And so it let people really prioritize where they focus their efforts when they have like an actual real event happening live across the environment. That's more than just developers' responsibilities. It's more than just the incident response people, right? It's everybody working together to mitigate this potential risk.
Right. And you said it somewhere there, but really it's also, I think, a key element in those, like controlling the next 0 day, is that when it happens and there's a great stake for a lot of organizations, then it also causes the resources for application security and for companies to be, to not have the resources to answer everyone. So, at those cases where a company relies on even teams who, they have agreement to, they know that they should respond to, but in real time that like a real big event happens, they're unavailable. They're not available. And that's what happened to us when we started to have, in that incident of Log4j, when people asked us for help, and we said, it's not our job. You have teams that help you, and they said they're unavailable, and that's when you understand that security teams need to have that capabilities, and they cannot rely on external kind of help, and also once, as part of our in that incident, as part of our trying to help our customers and generally the let's say the community trying to help them, people created tools, right? Tools to check if you're vulnerable. Even Snyk and I believe Sysdig, but also in that point, okay, even if I have a tool and I have 10 different environments and I'm working against the time, I want to focus. I still need that focus to say, okay, I'm going to run this tool first on this, second on this, third on that. So the only way to kind of get that that real world in the wild know-how of where to start, you have to have kind of that insight that you just showed. So thanks. And I'm going to go over a few. I saw during the presentation that people asked a few questions, so I'll address a few, and then a few I'll leave to the Oh no, I see we have a bit. Okay, I'll leave them to the in a few minutes. I'll address all the questions. But if you have any questions, then put it. I'm going over them and kind of sorting them out as I do, and I'll try to answer everything. And maybe Alex could also. So about the playbooks and challenges. So again, a lot of people think that incident response, it's not what their day-to-day, it's not what they're used to do, and it sounds maybe intimidating, I think, for a few, but actually, I think when you go down to the main things and main spots, it's just about not thinking of it during the incident. It's kind of having some small checklists. It doesn't have to be in depth and covering everything, but it's in time of event, and it can grow and become more and more detailed as you progress with your response capabilities. But it gives so much kind of a peace of mind that you're doing the correct kind of things and not thinking under pressure what should be done. And also it gives you a time that you can, ask around, ask your co-workers, ask people, from the industry or post it or whatever, and get kind of feedback, and not everything being done in this stress-timed manner that you're in during a incident response. So, as an example, I wrote a malicious package detection. Okay, so malicious package, it's something that I think kind of gained a lot of attraction from attackers in recent years. I think it's probably the most growing, the currently most growing vector of attacks. And why? Because it's very lucrative for attackers. If they manage to hijack a package or do a kind of a confusion attack, then it holds a lot of thousands and sometimes millions of installations over countless environments for the attackers, and then they just need to go out and pick and choose who's the victims, or they can automate a lot of things. And so I think it's a very scary kind of event to start dealing with as it happens. Why? Because it's complex. There are CI/CD. It's because it relates to CI/CD. It goes also to developer station. It can have basically the remote code execution in CI/CD environments and production environments if this hits, if it's running, if it passes like the tests of and so we're just kind of making sure that we have all of these components to start asking the questions and not be stressed about it. So again, there's a list. I don't think I'll go over it, but if you have, I don't think you also need to be like some genius to kind of create those kinds of lists. It's a lot of them just make sense, but it also needs to be customized to your own organization. That's the crucial part, because it has the personas that relates to, if you talk about CI logs, so you have to know who can make sure that you've gone through all of the environments of different CIs. Why? Because it's not a one thing. CI can have very different kinds of sorry, I get confused. Okay, very different kinds of CI and more than one environments of CI. So and so there are also other challenges that you cannot really predict. For instance, that's a challenge that I encountered when I was investigating some malicious package, and then I found out that the source code was not available because the maintainer, the owner of the package, just unpublished it, which is something that you can do. So this is another risk that you need to think about. How do you address it next time? What can you do to store aside every package that you use, or use other measures to encounter this gap, but it could happen. And with that, I'm going to go to the questions.
Yeah, super. Yeah, we've got a bunch of questions in here. Great presentation so far. First question we've got from Steve, who's wondering, how do you foresee the development of AI affecting the modern AppSec attack surface? And maybe I'll kick that one to Alex to kick off, and then and then Omer, if you have anything to add.
Yeah, sure. I mean, that one's interesting. Basically, what we're going to be seeing is a lot of things going on around kind of what access the AI engine has, or what data the AI engine has access to, right? The more you give it, the more useful it can be. However, the more data that can be leaked out. And the other aspect of that is going to be around prompt engineering, right? There's a lot of things you can do around an AI model to give you information when it thinks it's not giving you information, right? So things like using acrostics or other ways to get to sensitive information and have it spell it out for you in various ways. And so I think it's going to quite change the way we handle interaction with things. This is going to kind of be a new area for us to explore and have to deal with. So
I've got a good relationship with Brian.
Okay, great. Omer, did you want to add anything on that one?
I just want to add that for us in the AppSec, so a lot of people go and think of AI, but generally when we use AI as a service, it is quite similar to any other API or external API we use. And when we are developing a module, then that's like a different story. And that's something that you need to kind of understand better, the risks.
Okay, super. Hey, Alex, there's a question here from Sarah who's wondering, how do Snyk and Sysdig collaborate to detect and mitigate zero-day vulnerabilities in containerized environments? And what specific features or techniques do they employ to address these emerging threats?
Yeah. I mean, the thing we're really using is kind of an API-driven integration between the two products. And so we are shipping over a lot of the data that Sysdig pulls to Snyk specifically in a way that they can basically parse. And so it's really about helping Snyk tell developers and prioritize with developers where they have the biggest potential risks, where things are exploitable, where things can be hit. The Log4j example is kind of a good use case of that, where we're able to help identify exactly what environments have potential risks, have areas of access, and are things that we need to go look at in particular. The other area that we're finding a lot of work these days happening is around kind of third-party projects. So there's a great open source project out there called Backstage that's becoming quite popular among developers. And vendors like Sysdig and Snyk and others are integrating with that to help kind of have a central point of integration between these various products to help developers be able to kind of leverage the information in different ways. At the end of the day, it's about getting as much data as possible together in a way that is meaningful and useful to the folks who care about it.
Okay, super. Yeah, Omer, anything you wanted to add to that one?
No, I think he answered perfectly.
Okay, excellent. Well, let's see, Alex. I know you've got a hard stop here, so just want to give you an opportunity to give any sort of last thoughts, and then I'll we've got a couple more questions that I can direct to Omer here. But Omer, anything?
Yeah, no, I mean, I appreciate everybody's time today. I think it's great that we're all actively interested in this topic. It's an area where the more work we do up front and early on in the life cycle, the better we are down the road, right? So the more things we can do to integrate together and just collaborate together, the better off we are. In particular, being able to kind of marry the developer operations with the security operations groups, bringing those two together, I think is a huge thing for all of us. The more we do there, the better off we all are.
Okay. Well, Alex, thanks so much for your time and your insights today. And we'll let you go. And Omer, I'm going to keep you on the hot seat for a minute here, if you can. All right. No problem. Thanks, Alex. All right. So, Omer, we've got a question here from Bill about how can the principles of ASPM be leveraged to align application security practices with the agile DevOps and cloud native development processes?
So I think that question really captures the tension, okay, of that ASPM is trying to solve. So the kind of tension is always been right development and development velocity, and that's where cloud native basically jumps in. It allows you to be very agile and very and they develop very fast and kind of lose all infrastructure related development where you just want to have your developer work on the logic of its application. And then ASPM comes and say, okay, but creating an application is more than just the stack that runs in one confined environment. It goes to different aspects, different environments, different teams, different, not every line of code was created equally, as much as it might hurt some lines of code, but not each line of code has the same risk as its neighbor, okay? And not each project, not each developer that works on some service has the same kind of risk as a developer or a development team that's working on a very, I don't know, like the heart of the authentication process or PCI environment and so on. So that's where ASPM comes and leverage and goes and say, these assets relates to this assets relates to this, and this what constitutes as risk. And so I hope that answers how the principles of ASPM can help.
Okay. Yeah, excellent. We've probably got time here for one more. There's another one from Bill, who had a lot of questions. This one is, how can the implementation of automated security testing and vulnerability scanning tools be optimized within a CI/CD pipeline to ensure minimal disruption to development velocity while maintaining a high level of security assurance in the application code base?
Right. So I have to say that, first of all, it goes back to what I just stated about the risk. I think also, we come to understanding that you cannot hurt development. You can't hurt development without a very good reason and without a way to explain it. So, and I think that in many ways, security kind of got off the hook for a lot of things just because of its importance and its and that it was obligated and so on. But I don't think we can get off the hook that easily today. I think we need to be held accountable for every failing tests, and that's also where the risk is coming to say, okay, here is where we need to be very, very hard on every failing build, and this is where we don't need to be very, very hard. And turning those dials and saying this is highly important and this cannot tolerate this kind of risk, and that may tolerate this kind of risk, is where the application security team needs to be, like turning those dials. So I hope that also answers as how to CI/CD can be. We can't see everything as a simple single kind of single layer security. Security goes in different aspects in different places. So you don't just say, okay, I do Dust V, I need to do Dust differently in different places. I need to have a policy that states why, and I need to have the developer who's failing to say, okay, this needs to be changed, the policy needs to be changed here, or I need to fix it, but I can't just ignore. It doesn't work. Yeah.
Okay. All right. Well, I think it's going to be a good place to leave it. Omar, this has been a fantastic session. Really appreciate your time and all your insights today. This has really been great.
Sure, I was very happy to be here and share this, and would be happy to have any kind of feedback from anyone here. I'm sure you can find a way to reach us all. Okay. And thank you again for having me.
Thanks a lot. All right, and we do have one more piece of business here, and that is the Amazon gift card prize drawing. And the winner of the prize drawing today is Sam Ratuda from California. So congratulations to Sam. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Snyk and SysDig for this session, and Snyk for making this whole series possible. Speaking of which, we'll see you next time for Chapter 5, which is about what a successful AppSec program looks like. That one will take place on March 19th at noon Eastern Time. So Chapter 5 is going to cover common challenges for security leaders involved in developing applications, securing applications, and eliminating potential business risk in order to answer the question, is this working? So it's going to be another informative session, and we will see you there.